Have you ever seen a satellite image of a hurricane swirling over the ocean? That massive, spinning vortex of clouds and wind is one of nature's most powerful displays. But how big do these storms actually get? Well, that's what we're here to explore today. We're going to dive into the incredible sizes of hurricanes, from the smallest to the most monstrous, and even see how they stack up against other planets. Stick around, because some of these comparisons will absolutely blow your mind. So, when we talk about hurricane size, what are we actually measuring? It's not as simple as you might think. We're usually talking about the diameter of the storm's wind field. Specifically, we look at the extent of the tropical storm force winds, which are winds blowing at 39 miles per hour or stronger. This gives us a good idea of the storm's overall reach and destructive potential. Think of it as the storm's footprint on the planet. A large hurricane can affect a huge area, even if its strongest winds are concentrated near the center. Let's start with the average hurricane. A typical hurricane in the Atlantic Ocean has a diameter of about 300 miles, or roughly 480 kilometers. To put that into perspective, that's about the distance from New York City to Richmond, Virginia. So, if the eye of an average hurricane was over Washington, D.C., its tropical storm force winds could be felt from Philadelphia all the way down to North Carolina. That's a massive area to be impacted by a single weather event. These average storms are already incredibly powerful, capable of causing widespread flooding and wind damage. But of course, not all hurricanes are average. Some are surprisingly small. Meteorologists sometimes call these pinhole or midget hurricanes. One of the smallest on record was Tropical Storm Marco in 2008. Its tropical storm force winds extended only about 12 miles from its center. That's a total diameter of just 24 miles. You could drive across it in less than half an hour. Despite its tiny size, Marco still brought heavy rainfall and flooding to the coast of Mexico. It's a powerful reminder that size is unto everything when it comes to the danger these storms pose. Even the smallest ones pack a serious punch. Now, let's go to the other end of the scale, the real giants. The largest Atlantic hurricane ever recorded was Hurricane Sandy in 2012. You probably remember this one. Sandy was an absolute behemoth. Its diameter of tropical storm force winds stretched over 1,100 miles, or about 1,800 kilometers. That's nearly the distance from Miami to Maine. Sandy was so enormous that it affected 24 states in the U.S., from Florida to Wisconsin, causing widespread power outages, coastal erosion, and catastrophic flooding, especially in New York and New Jersey. Its sheer size was a major factor in its destructive power, creating a storm surge that was unlike anything seen before in that region. But even Sandy has a rival for the global title. Over in the Pacific Ocean, they have typhoons, which are the same phenomenon as hurricanes, just with a different name. In 1979, Typhoon Tip became the largest tropical cyclone ever recorded on Earth. At its peak, Tip had a staggering diameter of about 1,380 miles, or 2,220 kilometers. That is almost half the size of the entire contiguous United States. If you placed Typhoon Tip over the U.S., it would stretch from the coast of California almost to the Mississippi River. Its clouds would cover nearly everything west of Dallas. It's almost impossible to comprehend a single storm being that large, a swirling weather system covering a massive chunk of a continent. So, we have these colossal storms on Earth, But how do they compare to storms on other planets? This is where things get truly humbling. Let's travel to our giant neighbor, Jupiter. Jupiter is famous for its great red spot, a storm that has been raging for at least 350 years. This isn't just any storm. It's an anticyclone, a high-pressure system spinning in the opposite direction of a hurricane. For a long time, the Great Red Spot was so big that you could fit 3 Earths inside it, side by side. Imagine that. A single storm wider than our entire planet 3 times over. In recent years, astronomers have noticed that the Great Red Spot is shrinking. But don't let that fool you. Even at its current, smaller size, it's still about 10,000 miles, or 16,000 kilometers, in diameter. That means it's still wider than the entire Earth. Our largest storm ever, Typhoon Tip, with its 1,380-mile diameter, would be just a tiny speck next to Jupiter's colossal storm. It's like comparing a grain of sand to a basketball. It really puts the scale of our solar system into a mind-bending perspective. And Jupiter isn't the only gas giant with monster storms. Saturn has its own massive storm systems, including a bizarre hexagonal storm at its north pole. This hexagon is a persistent weather pattern with sides about 9,000 miles long, which is wider than the Earth itself. Inside this hexagon, other storms, like hurricanes, form and dissipate. In 2010, a massive storm known as the Great White Spot erupted on Saturn. It started as a small disturbance, but grew to encircle the entire planet, stretching for 190,000 miles. It was a storm that literally wrapped itself around a world. Even further out, on Neptune, we have the Great Dark Spot, discovered by the Voyager 2 spacecraft in 1989. This storm was about the size of Earth. It was a massive, dark, swirling vortex, similar in structure to Jupiter's Great Red Spot. Interestingly, when the Hubble Space Telescope looked at Neptune a few years later, the Great Dark Spot was gone, but a new one had appeared in the northern hemisphere. This tells us that even these planet-sized storms can be temporary, forming and dissipating over a matter of years or decades. So, coming back to Earth, what determines the size of a hurricane? It's a complex mix of factors. Things like the temperature of the ocean water, the amount of moisture in the atmosphere, and the surrounding wind patterns all play a crucial role. For a hurricane to grow truly massive, like Sandy or Tip, it needs a huge area of warm ocean water to feed on, and it needs a very calm upper atmosphere with little wind shear to tear it apart. When all these conditions are just right, a storm can expand and grow into one of these terrifying giants. From the tiny but potent tropical storm Marco to the continent-spanning Typhoon Tip, and then to the planet-swallowing storms of Jupiter and Saturn, the universe is full of weather on scales we can barely imagine. It's a powerful reminder of the incredible forces at play, both on our own world and across the solar system. Our hurricanes are devastating and immense by human standards, but in the grand cosmic scheme, they are just small ripples in a much, much larger ocean. Thank you so much for joining me on this journey through the incredible sizes of storms. I hope it gave you a new perspective on the weather we see here on Earth. If you found this fascinating, do not forget to hit that like button and subscribe for more deep dives into the wonders of our universe. See you in the next video.